One of the simplest widgets for presenting information to users is the label, which can be used to display lines of text and/or an image. Labels are typically used to identify controls or provide visual feedback to the user. You've already seen the label widget used earlier for text in the Hello TK-Enter example, so let's go into detail about creating and configuring a label now. In this video, I'm going to use the Python shell as an interactive interpreter so you can see the results of each command as I execute them. As with all TK-Enter programs, the first thing we need to do is import the TK-Enter package by typing from TK-Enter, import asterisk. And then with the label, it exists within the themed TK module, or TTK module, so we'll need to import that as well. Now, to create a top-level TK window, I'm going to use the TK constructor method and store that top-level window, or reference to it, in the variable called root. And to create a label, which I'm going to store in a variable called label, I'm going to access that theme TK module. So I type TTK, and then I'm going to use the label constructor method. And note that label is spelled with a capital L. This is common amongst all the constructor methods. As with all constructor methods, the first parameter is the parent widget of this label. In this case, it's going to be the root top level window. And then we can add additional properties. So I'm going to go ahead and configure it to say Hello TK-Enter, something we've already seen before. And that creates the label widget object. But to make it display on the screen, I'll need to use the geometry manager. So I'm going to call the pack method to use the pack geometry manager. And when I execute that, you can see it's now displayed up here. The size of the label object is as big as it needs to be to hold the text, and then the frame with the pack manager will be squeezed in around that label. After I've created the label, if I later want to change the text programmatically, I can do so with the config command to change that text property. So I type label.config text equal howdy TK-Enter. You notice in real time, as soon as I execute that command, the text in the label has changed. I could also make that text something really long. So say I have a very verbose welcome. I say, howdy TK-Enter. It's been a while since we last met. Great to see you again. And if I enter all of that into the label, you notice that the label stretches out as long as it needs to be to contain that on a single line. And as you could imagine, if I insert this much text into a label within another program, it could cause the GUI to stretch out in ways I might not like. So I can cause this label to wrap the text onto multiple lines by configuring the wrap length property. So I'll do wrap length, and you provide wrap length with a number being the number of pixels for the text to wrap around. So by setting wrap length to 150 here, I've configured this label to wrap the text within 150 pixels width. You notice that by default, the text is justified and aligned to the left side of the label. We can configure which side it's justified to by configuring the justify property. Options for the justify property are left, right, and center, and you type them in all capital letters. So in this case, I'm going to center the text within the label. And you can see now, instead of being justified to the left side, our text is centered. Some other properties that we can configure for the label are the foreground and background colors. The foreground property sets the color of the text, and the background property sets the color of the label area. So if I set the foreground property, the input is going to be a string, and you can insert a hex value here, or the name of common colors, such as blue, red, yellow, and so on. So I'm going to set my text to be blue, and then I can also configure the background property, which will be the color of the label itself, and I'm going to set that to be yellow. Some Python-themed colors here. We can also configure the font of our text by using the font property. To set the value of font, you pass it a list, with the first item being a string containing the name of the font you want to use. So in this case, I'm going to use Courier. The next item in that list is a number, being the size of the font. And then after that, you can optionally pass it a third string containing additional modifiers such as bold, underline, italic, and so on. And that, as I execute it, changes the font. We'll also look at another way to change the font of labels and other widgets using the style property in a later section on the course when we cover the style TK object. That covers the basics for using the label widget to display text on single or multiple lines. Now, let's look at how we can also use the label widget to display an image instead of just text. Before I move on, I'm going to change the text of our label to be a much shorter message. Go back to the original howdy TK-Enter. And then to add an image to our label, we first need to create a photo image object. And the photo image class is used to display color images within tkinter. It can accept GIF, PGM, or PPM files. So if you need to use another file type than one of those three, you'll have to use an external library to convert it to one of those. An example of this could be the Python image library. There's also a bitmap image Python class, which functions similar to the photo image class we'll look at in just a second, except that it only accepts 2 color images in the .xbm format. To create a Python photo image, we use the photo image constructor method. It's spelled with a capital P and a capital I. And then we configure the file property within that. And for file, we pass in the path to our photo image. I have that saved to my clipboard here. And I'm going to be using python_logo.gif, which is included in the exercise files for this course. And you'll see that this call creates a tkinter photo image object. I made a mistake there. I actually want to save this to be able to use it to a variable. So I'm going to pass it in and save it to a variable called logo. So now that I have my image saved in a variable called logo, to apply it to my label, I need to configure the image property. You'll see now we've replaced that text with the image and it's displaying the image instead. So our label has 2 properties configured. It has the text property configured to a value for text, and it also has an image associated with it. We can control which one is displayed by changing the compound property. So we can switch back to displaying that text by setting compound equal to text. If we wanted to show the image again, we could set compound to image, or we can do something more interesting. We can display both at the same time by using some other compound words. So for example, if we set compound to be center, it'll display the text on the center of that image. Some other options for compound are top, bottom, left, and right. So commonly used one would be compound left, which will display the image to the left of the text. And this is something you'll commonly see in buttons and menu items where you have a small image, an icon image, next to text. Now I want to finish the section up by pointing out one gotcha with images that tends to trip up new tkinter programmers. And I'm bringing this up because I stumbled across it myself when first learning to use tkinter. The call image equal logo to configure the image property is not actually saving a copy or reference to the photo image object. It's only using the name of the photo image object to pass to TK. This means if our logo image goes out of scope, Python will garbage collect it and TK won't be able to display it anymore. Everything worked fine in this example because we're operating inside an idle and the photo image object remained in scope. However, if we had created that photo image object inside of a function and only stored it to a local variable in that function, then when the function completed, the photo image object would be garbage collected and the image would disappear from our GUI. Similarly, if we'd created the photo image object in a class constructor method and stored it to a class variable, when the object instance in which the photo image was created and stored loses scope, it'll be garbage collected, and the photo image object will be taken away too. For these reasons, you should always make sure that you store the image object to a variable location that will not be garbage collected as long as you need to use it. One workaround to use this is to store a reference to the photo image object in the TK label widget object itself, since TK is holding onto that widget and preventing it from being garbage collected. We can do that by typing label and creating an image variable within that label object and passing in logo so that we've saved a reference to that logo inside that image variable. And now that we've done that, we can configure the label to use that image instead by typing image equal label.image. Now the photo image object will stick around for as long as the label exists because it's stored within that label. You may think this is a bug in tkinter at first, but really it's there to help prevent accidental memory leaks due to unwanted photo image objects hanging around. I wanted to point this issue out because it's one that you'll almost certainly run into at least once during your time programming with tkinter, and now you know what to look for.